All right, so page 316, number 34, we have an equation, a polynomial here. I've circled this first. Circled this first one. That is the leading coefficient. Its factors go down here. When you're trying to find all the possible rational roots, okay, the factors of 6 will go on the bottom. When you're trying to find the factors of your constant, okay, I put this in this little blue color. 15 is the constant. It has no variable with it. Those factors go on the top. Now, keeping in mind that we're trying to find all the possible rational roots. Rational numbers are either integers or they're fractions. All right, so it's one of those two. All right, so what we do is we start writing these fractions, right? So we looked at that. We've got that. We're going to write the factors of our constants on the top and the factors of our lead coefficients on the bottom. And that will make us form some new numbers. So I've already started a little bit here. So let's go back to this constant over here. Okay, let's go back to that constant. The constant is 15. So if you want to write the factors of that, factors of 15 are 1 and 15 and 3 and 5. And then factors of your lead coefficient, since lead coefficient is 6, it's 1 and 6 and 2 and 3. And then what we're going to do is to write all those out, we're going to make fractions. So we're going to put like 1 over 1, 3 over 1, 5 over 1, and 15 over 1. That's where I got these. They're all positive, negative. Then we're going to move over to the 2. So once you've already put everything over 1, then you move over to the 2, and you can write those. So we're going to put 1 over 2, 3 over 2, 5 over 2, and 15 over 2. So the 2 is finished. Then we're going to move on to the 3. So we're going to have 1 over 3, 3 over 3, 5 over 3, and 15 over 3. So 1 over 3. Now, when I do 3 over 3, 3 over 3 is just 1, and I already have 1, so I don't need to do it again. And then we go to positive negative 5 over 3. And then we look at 15 over 3. Well, that's actually 5, and I already have that one, so we don't need to write it again. So 3 is finished. Now we're going to move to the 6. So we're going to do the 1 over 6, 3 over 6, 5 over 6, and 15 over 6. So 1 over 6. Now, the 3 over 6 is really just 1/2. But I already have 1/2, so I don't need to do those again. And then, so that was 3 over 6, and now we're going to do 5 over 6. And then when we're looking at 15 over 6, when you put that in lowest terms, you can divide by 3 on top and bottom. You already have that right here. Actually, not right there. We have it right there. So we don't need to write it again. So we have listed all of our possible rational roots. These are all of them. These are all the possible rational roots that we might have. Now, it looks like a lot, but that's better than having an infinite number of possibilities, because before we did that, we had an infinite number of possibilities. You may have tried, if you want to know the roots, you may have thought, hey, I'll try 2, but 2 is not even an option. Okay, so we've narrowed it down. Something else that we could do, sometimes it helps, sometimes it doesn't, is we can use Descartes' rule of signs. That will tell us how many positive and how many negative real roots. Now, real numbers are everything except imaginary. So except imaginary. So to do this, if we want to know how many positive real roots we're going to have, instead of an x, wherever you see the x, you're going to plug in a positive. Now you can actually use like +1 if you want, but what we're doing is we're looking to see what happens to the signs. So if you have a positive raised to the 4th power, that's a positive. So when you take that positive times this positive, you get a positive. When you take a positive to the 3rd power, that's positive, but when you multiply it by that negative, you get a negative. Positive squared is positive, times that positive is a positive. Negative times a positive right there is a negative, and then this last one is just negative. So then you go back and look to see how many sign changes just occurred. Well, as you go left to right, okay, so as we're looking left to right, going across here, you see that there's a sign change. We went from positive to negative, then we went from negative to positive, then we went from positive to negative. So that actually has 3 sign changes. It's kind of like when we're doing the turning points, though, you could have 3 or 1 positive. So how many positive real roots? We could have 3 or 1 positive real roots. So that really doesn't help us much on that one. So then let's try the negative. Do the same thing, but instead of a positive, we're going to plug in a negative. Now, if you want to use like -1 there, you can if it helps you. So a negative to the 4th power is a positive, times this positive gives you a positive. Negative to the 3rd power is negative, times that negative gives you a positive. Negative squared is positive, times the positive is a positive. This negative times a negative is going to give you a positive, and then the last one's a negative. So as you go left to right on this one, as you go across there, there was only 1 sign change. So that tells us there's going to be one negative real root. All right, now, this really doesn't help a whole lot on this problem because we know there's going to be a positive, at least 1 positive and at least 1 negative root. We may have a couple more positives. So we definitely know there's going to be 1 negative, but we know there's going to be some positives too. So it really doesn't help us narrow down which numbers we need to use. What's best is when you work one of these and when you get 0, that means, hey, if we found, I'll do a little what if. What if you did that for the positives and had 0 sign changes? Well, then don't try positive answers. Don't try positive roots when you're doing your synthetic division. That's what that tells you. So on this problem, you've got all your options here. Okay, you got all these options. We know we're going to have positive and negative roots. So you just start in with, usually starting with the first one, you try 1. So bring the 6 down, then you multiply 1 times 6 and put it there. Okay, remember we bring this down, and then we multiply these 2, and it goes there. You multiply, then you add. Okay, so we multiply these 2, it goes there, then you add. Then we're multiplying these two, it goes there, and then we'll add. So 1 times 6 is 6. When you add, you get this. 1 times negative 33 is negative 33. Now, when you add here, we are not getting 0 as our answer. This part right here is always your remainder. If you're not getting 0, then that means this thing you just divided by doesn't work. So 1 doesn't work. All right, so then you could try negative 1. Sometimes this takes a while. So you bring the 6 down, you multiply, you add, you multiply. We're getting big numbers here. You multiply, we're getting huge numbers now. That's not going to be 0 either. So that doesn't work. So then you go and you try the next one, and you keep going. So we know that this doesn't work. You keep going. All right. So I'm going to give you a big hint here on this one. All right. It's either going to be positive, negative 5/2. One of those is going to work. All right. So let's try the positive version. So the other answer is going to be a fraction also. The other real number that's going to work. So we're going to put these down here. Sometimes you go through all those numbers. It is possible that we could go through all those and none of them work. So if you run into that, well, you need to realize that, hey, at least you practiced synthetic division, and you ought to be really good at it by the time you get finished. All right, so now we're going to multiply. We take 5/2 times 6. So 5/2 times 6. So we put it over 1. You get 30 over 2, which is 15. Then we add. Then we take 5/2 times 2. You take 5/2 times 2. You get 5, and then you add. You take 5/2 times 18. You get 45, and then you add. You take 5/2 times 6, you get 15. And when you add, you get a 0. That means that 5/2 is one of your roots. Now, before you take off on the next one, you need to remember, don't start back at the very beginning. This is your remainder. This is your constant, the 6. The one in front of that is x to the first. The one in front of that is x squared. The one in front of that is x to the third. So instead of going back to the beginning, use these numbers. So I'm going to use the 6, the 2, the 18, and the 6 this time. Okay, that's what you want to go with. It's kind of like when you do a factor tree. If you had 24 and you break that down to 4 times 6, well, you don't go back up to the 24. You continue with what you have here. It's the same idea. Okay, so we found that 5/2 work, so we're going to take what we got from there on our next step. Something else that you can do at that point, you can also go back and look at your constant and your lead coefficient. Because now when you look at those two numbers, this one is the same, the lead coefficient, but this one is not. So you can actually go back and redo all of these up here. You could redo them and knock some of them out, because now we would have our factors of this lead coefficient on top over that coefficient or the constant on the bottom. It's like some of these won't even apply. All right, some of them won't even hold true. All right, just something to think about. You can kind of reassess what you've got. All right, so I'm going to give you a hint that for this one here, you want to try either positive or negative 1/3 and see if it works. And to save ourselves a little time, I know that it's negative 1/3. So I'm going to go ahead and work that one out so we can see what's happening. So negative 1/3 times 6 is a negative 2. You add, you get 0. 1/3 times 0 is 0. You add. Negative 1/3 times 18 is a negative 6, and we get that. So here's another root. All right, so now at this point, I'm going to erase some stuff just to give us a little more room so I can show you what's going to happen with this now. So now we have found, this is your remainder. This is your constant, 18. There is no x term, but this over here is an x squared. So what we actually have right now, all right, if we look at this thing right here and we think about what it factors to, we know that that thing will factor to x minus 5/2, x minus a negative, which becomes a plus 1/3, and then what we have left is this down here, which is 6x squared plus 18. So at this point, you can actually find the zeros of your function just by looking at this. Obviously, we know that if you set this first one, you set this equal to 0, you would get your 5/2. Same thing with the second one. It gives you a negative 1/3. But when you set this one equal to 0, and you start solving, you would subtract 18. You would divide by 6. When you square root both sides, you have to throw in the positive negative. And then we find that x is also equal to positive negative I square root of 3. Now, I believe the directions told us just to find the rational roots, which would be right here, but we also found the other two. Okay, we also found those. I know that's a lot of scribbling, but I hope it helps.